The really cool thing about Paimon is that it's compatible with Iceberg for reads, right? So I mean,
that's a big thing you raised there, because most of the time I'm seeing all these people trying to over-engineer for the upsells or the change data gaps or the schema evolution. I'm like, it's a single line command with Paimon. Just run this thing. It takes care of the schema evolution, not just with Kafka, with some proprietary solutions, but also with databases. Use that, do the ingestion, it's high throughput, it has schema evolution, and just use Apache Iceberg. Okay, you prefer to over-engineer things and reinvent the wheel. I mean, okay, but the solution is there for everyone.
So maybe since we've started moving in this direction, I'm guessing that a lot of the viewers are not familiar with Paimon. Could you give us kind of high-level introduction into what this is?
So for those of you that don't know, Apache Paimon is an open table format that was introduced by the Flink community. What it actually does different, the reason that Paimon was introduced was not to be just yet another table format, because we already had 𝗤𝗲𝗺𝗀, we had Iceberg, we had Delta Lake. The goal was to bring streaming and stream processing directly on the data lake house. So basically, for years, and as I said before, the only solution we had was Kafka and Flink, right? And this is also because of Kafka for the most part. Streaming and stream processing has been perceived as something expensive expensive and complex. With Paimon, the goal was to bring the stream processing with Flink directly on the data lake house to make it more cheap and cost efficient. So basically, all the reports I have, after, for example, if you can afford actually that latency, right? Because it's for near real-time latencies, typically to the minute level. If you can afford that latency, you get the solution that can be up to 80% cheaper. And you can do basically similar with Flux and the same, basically they share a lot of design principles, but the difference is that Paimon, again, is for low latency. You get all these things like streaming materialized views. Like, you don't just do ingestion as you would do with Iceberg. You ingest the data, but then because it also has changelogs, you can consume them and create other tables. So basically, you have streaming materialized views directly on the data lakehouse. All the changes get propagated. You have things like consumer groups directly on there. You have both append-only tables and primary key tables. Deal with upserts. You have the merge engines, which you can use out of the box to create business aggregates in the streaming way, and things that reduce the complexity of large streaming joins you will have to do with Flink, like streaming lookup joins or partial updates, and many other things. It also has some cool features that Iceberg also has, like, for example, the branching. The branching functionality is really amazing because you can create different branching from your dataset, like a Git-like, let's say, functionality, have different branches for streams, different branches for paths, do backfilling, everything. Basically, we have lots of technology there. The solutions is there. It's just about awareness for the most part.
Yeah. Like, for me, the key differentiator for both Paimon and I think Flux as well, because Flux has primary keys as well, right?
Yeah, we can touch on that later.
Yeah, so for me, the key differentiator was like something that really caught my attention was that this is an open table format that has primary key support, and how it's done is that you have this changelog as ingestion, right, memtable. That's kind of an in-memory buffer, but you can consume from it directly as well, as far as I understand. But then every specified period of time, let's say a minute or 3 minutes or whatever, this gets compacted, and then all of the changes gets compacted. So only like one change per primary key remains, and then this gets merged into this large LSM tree that has a primary key index. So the leaves of a tree. Oh yeah, I really hope for your corrections if I'm
and this is the point you make. I just didn't want to go deep dive into the specifics. The benefit that basically Paimon brought was that it combined the log structure mesh tree, the LSM, with actually object storage. So basically, when you hear about streaming and stream processing, you think about it. In probably, I think, almost every system, the log structure mesh tree Okay, with variations, obviously, sits at its core because it's a data structure that was designed for streaming. Like Flink has it, RocksDB actually has it, and Paimon put it on the object storage, but 𝗥𝘂𝗄 also has it. TimePlus using it. I think all the systems that 𝗥𝘂𝗄𝗃 has it. Bigtable has it. Lots of systems. So
yeah, but this is an analytical open table format, right? So so this LSM lives in cloud storage, in remote storage, and it's optimized for like long-term storage and analytical use cases. And the state can grow indefinitely while still getting you primary key based behavior, and really good support for retrieval by key.